All right, so hopefully you were able to answer the practice problems well. This is just going to be a review to the solutions for practice problems 1 through 7 for Unit 7 Waves, Notes 2. So starting with number 1, it says, what two things can be measured on a wave that can determine the energy a wave has, and how do these measurements help determine the energy of a wave? Well, if you recall from the notes, there were two things that influence the energy. The first one being amplitude, and the second one was wavelength. So we're gonna make sure that we keep those in the same color, and we're just gonna put a little arrow here. So a high amplitude is equal to a high energy. That's what we can remember. The higher the amplitude, the higher the energy. All right. For wavelength, the shorter the wavelength, so smaller wavelength, shorter or smaller, is going to result in higher energy. So over here, the relationship is kind of backwards, where the shorter this gets or the smaller this value gets, the more energy it requires. Whereas over here, the larger the value gets, the more energy it requires. All right, so that's number 1. Number 2 says this: represent the wave created by a pendulum that oscillates with an amplitude of 2 centimeters and a period of 1 second. Okay, so basically we're creating a graph here, and I'm just going to use these graph marks over here as my units here. So I'm going to put this over here as 1, and this one is going to be 2. So this one's going to be -1 over here, and this one's going to be -2. And don't forget that we have to label all of our axes on a graph. So this is going to represent centimeters. So I'm going to put cm here on the side. On the bottom here, it says a period of 1 second. So this is going to be time in seconds. All right, so we are representing this wave movement. The only thing that we're missing here is the units for time. We don't have to use this whole thing. I'm just going to mark out, let's say 1, 2, 3, 4, 5. That's going to be like 1/2 waypoint. I'm just going to put a dot there because I'm going to need it later. 6, 7, 8, 9, 10. That's going to be 1 second right there. So 1 second, this is going to be 0.5. And if we continue on, 1, 2, 3, 4, 5, so that's 1.5 right there. All right, you can draw this graph however you want it, just as long as you get the units right in correspondence to your wave. So we are representing a wave created by a pendulum, and it's going up and then down within 1 second. So what I'm going to do is I'm going to first draw the top part, the crest. I'm going to try my best to do this very carefully. And then I'm going to draw the trough. So then, yeah, I can already see that that's not really equal. So let me try that again. It's actually right here. That's the middle. So something like that. And then over here, that's 1, 2, 3, 4, 5. So about right there is the middle. So I'm just going to go from here, continuing downward. And then it's going to go up again. Well, it's supposed to hit that point right there, and then down again. Not the prettiest graph, but you get the idea that the amplitude here is 2 on either side and 1 wavelength. So if I started here, I could have ended here right there at 1 second. Another representation of this, I could have started this a little bit differently. You could have done this as well, and this would have been correct. You could start with a crest up here and have it go down here. And this goes back up. And it's kind of getting confusing here, so we have to make sure we get a crest up here. So that is technically correct as well. You can kind of see, if I were to draw this a little bit better, 1 wavelength is from here to here. And that it still qualifies that it has a period of 1 second and it still has an amplitude of 2. So that also would have been technically correct. All right, number 3, a pendulum with an amplitude of 5 degrees in a period of 4 seconds. So you can see here, we're basically just doing the same thing, practicing our graphing. We're going to put time on the bottom because that's what notes 2's told us to do. So we're going to put time in seconds here. And amplitude goes here, but in this time, we're going to measure it in degrees. All right. It says 5 degrees, and we only have 1, 2, 3, 4 boxes. So I'm just going to make, it doesn't really matter what we label this. I'm going to make this third one 5, and this third one here -5, and then this one's going to be 0. And then I'm actually going to bring it a little bit closer this time. So let's say this is 1 second, this is 2, this is 3, and this is 4, 5, 6, 7, 8, and 9. Okay, so what I'm going to do is just make sure that at 4 seconds here, the wave ends. At 2 seconds, which is the halfway mark, that's where the kind of trough is going to finish, or the crest is going to finish. So you can do this. And then down here, pretty much the same thing, just the opposite way. Make sure you hit that. Again, not the nicest waves. It's kind of hard to draw on a computer instead of a board. It's supposed to hit that, so imagine just one like that. Let's try that again. So maybe like that, and then like that, and then it just continues onward. So, oh, you know what I actually did? I wasn't paying attention to the axes here, so let's just fix that by saying the top here was 5 and -5. Technology, I can fix the whole thing pretty quickly. And now this would be correct. So it goes up to 5, down to 5, up to 5, down to 5, up to 5. And just to make sure that one wavelength, so if it starts at 0, one wavelength later, it ends at 0. One wavelength later, it starts at 0 again. All right, so another representation, you could have done the same thing that I did before by shifting it. You could even start it with a trough. So if you want to start with the trough instead, you could have done that where it goes just like this, opposite direction, kind of just doing it really sloppily. You get the idea of basically how to draw a period of 4 seconds and an amplitude of 5 degrees. Hopefully the next one I don't have to draw, and I don't. Good. A sound wave has a frequency of 192 hertz. What is the period of the wave? Well, we know a couple of things in the data. We know that the frequency is going to be equal to 192 hertz. The other thing the problem asks for is the period, which we don't know. Do we know an equation that associates the two? Yes, we know that frequency is equal to 1 over t, like this. So we know that frequency is 1 over t. We can kind of rework this equation so that it's t is equal to 1 over f. And that one was also in the lecture, so we could have used that one as well. So t is equal to 1 over, in this case it's 192 hertz. All right, and I don't have a calculator on me, but if I pull one out, 1 divided by 192 gives us a really small number, 0.005 is where we're going to leave it off. So t is equal to 0.005 seconds. Don't forget the unit is seconds there. So that's problem number 4. Moving on to number 5. A pendulum has a period of 0.3 seconds. What is the frequency? So we know that the period now is going to be 0.3 seconds. What is the frequency? That's what they're asking. And we know the relationship from the previous problem, that frequency is equal to 1 over t. Frequency is equal to 1 over 0.3. So frequency at that point is going to equal, just to double check my math, I don't want to be wrong in front of everyone, 1 divided by 0.3. Yep. It's 3.33 repeating, or we could just wrote that here in the solution. Frequency equals 3.33, the unit of course being hertz. All right, number 6. An oscillator makes 4 vibrations in 1 second. What is the period and the frequency? So the other equation for frequency was the number of waves divided by the number of seconds. Don't forget that. That's going to be very important. So this whole equation. The other equation, if you want to do for period, it's going to be the exact opposite. It's going to be the flipped version of this. It's the number of seconds divided by the number of waves. All right. So how many waves do we have? Well, it says 4 vibrations. You can say it's 4 waves. So 4 waves, and we have 1 second. So now we just have to do the work. So frequency is going to be equal to the number of waves divided by the number of seconds. So 4 divided by 1. Easy. Period is going to be the number of seconds. So we have 1 second divided by 4 waves. So that's also easy. So now we just put in the solution. Frequency is equal to 4 hertz, and period is equal to 0.25 seconds. All right, number 7, the last problem for Notes to Practice Problem Part 1. So the question asks, a pendulum takes 10 seconds to swing through 2 complete cycles or waves. How long does it take to complete 1 cycle? So it's asking for a unit of time. How long? Right? So it's either going to be in seconds or in waves. We know when someone asks how long does it take to do something, they're asking for a unit of time, and that would be seconds. So if it takes 2 cycles in 10 seconds, we can kind of assume that for 1 cycle to occur, that would be 5 seconds. Okay. So for number 6, remember that we had these 2 formulas. Number of waves divided by the number of seconds, and then this is going to be the number of seconds divided by the number of waves for period. So for period, let's do this one. Let's do T is equal to the number of seconds divided by the number of waves. So in this case, T was equal to, we had 10 seconds and we had 2 cycles or 2 waves. That's how we got 5 seconds as our answer. So part 1 here was basically the same thing as B. Frequency, there's 2 ways to go about this. You can either go number of waves divided by the number of seconds, or you could just take the inverse of this. The trickier way is to do the inverse, so let's do it that way. So F is equal to 1 over T. That means F was equal to 1 over 5. So F is equal to 0.2 hertz. And that's our final answer there. And this was this answer. All right, so that concludes Notes to Practice Problems 1 through 7.